Hello everyone, this is Dr. G. Anita, Hebsiba, Department of Chemistry, Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. Today we are going to discuss about the different theories behind the dyeing of textiles. The first theory is physical theory. According to the physical theory of dye-fiber interaction, dye molecules are retained by the fiber by means of van der Waals forces or hydrogen bonding. There is no strong chemical bond involved in it. Actually, a dye should be bonded to a fiber in such a way that it fixes to it. So in that sense, we are going to study about these theories. Some of the important characteristic features of this physical theory of dye-fiber interaction are the fastness of the dye increases with increase in molecular size. So when the molecular size increases, the solubility decreases. If the solubility decreases, the fastness of the dye will increase. So dye's fastness decreases as the solubility increases. So one of the most common example of dye showing this type of interaction is solubilized VAT, direct dye, sulphur and bad dyes too. The next theory is chemical theory. Here we have the dye-fiber interaction by means of a chemical bond. So very important characteristic features of this chemical theory of dye-fiber interaction are the dye and the fiber are required to have some reactive group. So by then only they can go for in reaction. Dye's fastness property decreases as the number of reactive sites increases. When the reactive site increases, the bonding will be more strong, and the dye's fastness property will decrease. In most cases, the bonding nature is ionic but can also be covalent in some cases. An electrolyte is added during the half dyeing process to exhaust the bath so that the dye can be fixed well. Sometimes the dyeing rate is so high that leveling agents are needed for a more uniform effect. So when the dye uptake is more high, we need leveling agents so that you need to get a uniform shade. So some of the most common examples included in such kind of dyeing are dyeing of wool and silk by means of acid dyes, cationic dyes, etc. So here this dye fiber interaction is by means of pure chemical bonds, that is covalent interaction. The next theory is physico-chemical theory. Here the dyes are applied to the fiber. The interaction is physical bond. To improve fastness of dyed textile, size of the dye molecule has to be increased by reacting the dye chemically with some other external chemical or dye by some after treatments. So there is some dyeing process, and then after treatment is also needed. One component must be a dye and the second component should be a chemical or a dye. So after treatment of direct dyeing with either of metal salt, formaldehyde, cationic dye fixing agent, basic dye, resins or diacetized base are very common examples. Other examples are backtanning of dyed protein fibers, modernting of cotton for dyeing with a basic dye, and modern dyeing method are common examples for physicochemical theory. The next theory is fiber complex theory. Here the dye forms a complex when it interacts with the fiber. So the dye fiber interaction happens by means of the formation of a complex. Some of the important characteristic features of the fiber complex theory of dye fiber interaction are a dye on its own is not able to enter the fabric's matrix due to lack of affinity for a large molecular structure. So it has to form a complex which has some affinity for the fiber. So in that sense, dye fiber theory or else the fiber complex theory holds good. It is usually for insoluble azodyes. Next one is solid solution theory. So here the dye molecules are trapped inside the fiber material under suitable conditions. So the dye stuff or the fiber or both are in the solid phase. Dye gets trapped into the hydrophobic fiber, forming a solid solution. The dyeing is carried out at a higher temperature to facilitate the passage of dye molecules into the fiber. Here is a very good example of this particular dye is dispersed dye. So dispersed dye, it's insoluble. So at a very high temperature, the dye molecules becomes fused into the fiber, and then it gets attached to the fiber. So the last one is pigment or mechanical theory. According to this theory, the dye has no reactive site, no affinity for the fiber, and it is insoluble in most of the solvents. The fiber becomes more stiff, and the dye's fastness property depends on the film's longevity. Thank you.